My name is Sarthak Chandra, and this is my project for my IE course, SecuriShield. My problem statement is as follows. As thefts are increasing day by day, security is becoming a primary concern nowadays. So a digital code lock can secure your home or lock it easily. It will open your door only when the correct password is entered. In addition to that, a theft alert system has been integrated which alerts the neighbor about an intruder with the alarm. In addition to this, resource conservation is essential for sustainable development and to prevent global warming. It has been statistically proven that by just turning off the lights and fans whenever not needed, we could save up to 4 kilowatt of electricity every day. The implementation details are as follows. To combat these problems, I have implemented a keypad-based lock that uses an Arduino, an NPN BJT as a switch. This NPN BJT is used to control the alarm, a piezo sensor as the alarm, an LCD display, and a microserver for controlling the doors. For the room automation, I have implemented the circuit using an Arduino, a motor for the fans, an NPN BJT as a switch, a piezo sensor as the alarm, an ultrasonic sensor for motion detection, a server for controlling the doors, a temperature sensor for finding out the temperature, a photoresistor for determining the amount of light in a room. Both these circuits run with Arduino code in the background. Let us talk about my contribution in both these aspects. My contribution alarm system was to add an intruder detection system. In case of an incorrect password being entered, 2 warning messages will be displayed before a whole emergency alarm system would sound to alert the neighbors about the intruder. About my contribution in the room automation system, the resources I found were mainly based on appliance control. I made the whole system automatic. I have added a motion detector system which automatically opens and closes the doors in a room, a light detection system which automatically detects the amount of natural light in the room and decides whether artificial lights are needed or not, a temperature sensor which automatically detects the temperature of a room and makes a decision whether or not a fan is required. Finally, a smoke detector has been implemented to detect any gas leaks in the room and trigger an alarm. This adds to saving natural resources and reducing electric consumption wherever electricity is not needed. I chose to use TinkerCad because it had a pervasive feature set, everything was readily available, it was straightforward to use, and I could simply start using it without any prior knowledge. Additionally, it suited my use case of home automation perfectly, where it had all the components I required. So, we do the door lock first. We use an NPN transistor as a switch to control the alarm. Let us enter the password. I have set the default password to be 4567. I have entered the password here. It shows the access granted, and now the door is automatically opened. It will wait a certain amount of time before the relocking procedure begins. And now the relocking procedure is over and the door is locked again. As you can see, the server moving back to its initial position. So what if we enter the wrong password? Here, as you can see, I've entered the first field wrong. So now it's issuing an alert. As you can see, the alarm only stopped when I entered the correct password and the unlocking procedure began again. Let us move on to the room automation system. This is the temperature sensor. When the temperature rises above a certain threshold, let me just set it here, the fan automatically turns on and brings down the temperature to the optimal level. Let's say the temperature returns to the optimal levels. Here you can see the fan automatically turns off and lets the natural surroundings take control. Next, we move on to the photoresistor. This detects the amount of natural light in a room. Let's say if the natural light in the room is above a certain threshold set. These bulbs automatically turn off and save electricity that is not required when the natural light falls below a certain threshold. Let's say in the evening, the bulbs automatically turn on, as you can see here. Next, we move on to our motion sensing doors. Whenever a person breaks the threshold line, ultrasonic sensor detects its presence. The servos automatically open the door. And when the person passes, the servo closes the door again. Lastly, but most importantly, we move on to the smoke detection system. Let us suppose there is a gas leak at your house. As simulated here, the smoke detector instantly triggers an alarm, which lets the homeowners know that there is an emergency at their house. So this was SecuriShield, a complete home automation system. I have modeled it to function as a whole package for consumers, which is intuitive and easy to use for everyone. It incorporates a secure environment that is safe from gas leaks as well as thefts, while being fully automated and resource efficient. Thank you.